Hello everyone. So today our topic of discussion is Rolle's theorem. Rolle's theorem. So to apply this Rolle's theorem, we must have a function fx which is defined in the interval a to b. So this fx should be given and this interval a to b should be given where a and b both are included, and this fx should be defined in this interval a to b. So according to this Rolle's theorem, there are three conditions that should be satisfying. So the first condition which should be satisfied by this function fx is this fx should be continuous in this interval a to b. Okay, so what is the first condition? The first condition is the fx function which is given to us, that should be continuous in this interval a to b. So let's write that. So this fx should be continuous in interval a to b. So this is the first condition. Now second condition. What is the second condition? Second condition is this fx, this should be differentiable in the open interval a to b. So let's write that also. This fx, this should be differentiable. This should be differentiable in a to b where a and b are not included. So this fx, this should be differentiable. This is the second condition. Now let's see the third condition. The third condition is f of a should be equal to f of b. What are these a and b? A and b are these points, the interval, the starting point of the interval and the end point of the interval. So this f of a and this f of b, these should be equal. So these are the three conditions that should be satisfying. So if these three conditions are satisfying, then according to Rolle's theorem, there must be a point C. There must be a point C. There must be a point C in the interval a to b. In this interval a to b, there will be a point C such that f of c, f dash of c, that should be equal to 0. That should be equal to 0. So this is the whole statement of Rolle's theorem. Now what is the significance of that and how to apply that theorem? So to understand that, we'll take some examples. By that you will understand this better. Okay. So first of all, to understand these three conditions, okay, we'll take some examples. Okay. So if a function you have given that is like this, this is a, this is b, and this is function fx, this you have given. So obviously this point, this will be f of a and this will be f of b. Okay, so this f of a is equal to f of b, that we can clearly see. Now let's see all these three conditions, these are satisfying here or not. So the first condition is fx should be continuous in a to b. So this is the interval a to b. In this fx should be continuous, but clearly we can see at this point this fx is not continuous. So here the first condition is not satisfied, so we cannot apply Rolle's theorem here in this question. Okay, now see another question or another example. Now if we have given a function like this, this is a, this is b, so obviously this will be f of a and f of b, and this is a sharp corner here like this. This point is what? This is sharp corner in this graph. So here, now let's check these three conditions, these are satisfying here or not. So the first condition is fx should be continuous. So this function fx we have given, this we can see this is continuous here. So first condition is satisfied. Now the second condition is fx should be differentiable in a to b. Now this function fx is differentiable or not. So by graph, how we can observe the function is differentiable or not? Now to understand that, we know that if there is a sharp corner in the graph, so at that point the function is not differentiable. So here we know this is a sharp corner, so this function will not be differentiable at this point, because at this point infinite number of tangents can be drawn. So the second condition is not satisfying here. Okay, so again we cannot apply Rolle's theorem. Okay, now see another example. Now if we have given this function fx like this is fx, this is point A, this is point B, so obviously this will be f of A and this will be f of B. Now let's check these three conditions again for this graph. So here fx should be continuous in into B, so this is continuous function here. Fx should be differentiable, so no sharp corners, so this is differentiable also. Now f of A should be equal to f of B. Now see this, f of A is this and f of B is this. There is a huge difference in there. We can see this f of A is not equal to f of B. Okay, so again this third condition is not satisfying. So here again we cannot apply the Rolle's theorem. Okay, so all these three conditions, when these are not satisfying, that we have seen. Now let's see when we'll apply this Rolle's theorem. Okay, now for that let's take one example. So x square minus 5x plus 4. Let's suppose this is function fx we have given and the interval we have given is 1 to 4. Okay, so we'll apply Rolle's theorem here. So we know now first of all we'll check these three conditions. The first condition is fx should be continuous in this interval a to b, or here in this case 1 to 4. So this is fx is a polynomial function and we know all the polynomials are continuous. So here this fx will be continuous here. Second condition is fx should be differentiable. So graph of this function fx, that should be a parabola and coefficient of x square is positive, so this will be a upward parabola. And we know the parabola graph is what? Differentiable in all its domain for all values of x. So this is differentiable also. Okay, or we can draw graph of this easily. Okay, so we can observe from there this will be differentiable also. Now f of a is equal to f of b, so this we have to check. Now f of a, what is a and b here? A is 1 and b is 4, because interval is what? A to b, here interval is what? 1 to 4. So a is 1 and b is 4. So we'll check what? F of 1. So f of 1 means what? In this fx we'll put what? 1 in place of x. So this will be 1 square minus 5 into 1 plus 4. So this will be what? 1 minus 5 plus 4. So this will be 4 plus 1, 5 minus 5, that is equal to what? 0. Okay, so this f of 1 is what? 0. Now f of 4 will calculate. So f of 4 will be what? 4 square minus 5 into 4 plus 4. So this will be what? 16 minus 20 plus 4. So this will be what? 16 plus 4, 20 minus 20. This will be again what? 0. So f of 1 is equal to f of 4, because both of these are 0. Both of these are equal, that is equal to 0. So this third condition is what? Satisfied here. So all these three conditions are satisfied. So we can apply Rolle's theorem here. Okay. So according to Rolle's theorem, there must be a point C. Okay. So let's check this point C is there in this interval 1 to 4 or not. Okay. So f dash of x will be 2x minus 5. That is differentiation of this. Fx is this. So its differentiation will be this thing. Okay. 2x minus 5. So let's suppose that point C. So f dash of C, so this will be 2c minus 5, and f dash of C is equal to 0. So by applying this, we'll find out value of C and we'll check that C that we are getting, that is in this interval 1 to 4 or not. Okay, if that is there, then this Rolle's theorem will be verified. Okay, so this f dash of C means 2c minus 5, this will be equal to 0. So from here C will get 5 by 2, that is 2.5, and we know this 2.5, this belongs to this interval 1 to 4. So 2.5, this belongs to 1 to 4. So hence this Rolle's theorem is verified from here. So now we will discuss some questions based on different concepts. So our first question is the number of integral solutions of x1 into x2 into x3 into x4 is equal to 210 is. Option A is 4 raised to power 4, option B is 6 into 4 raised to power 4, option C is 8 into 4 raised to power 4, and option D is 10 into 4 raised to power 4. So we have to find out integral solution of this given equation. Okay, so first of all, let's write this equation. This equation is what? X1 into X2 into X3 into X4 is equal to 210. This equation we have to solve. Okay, means integer values of X1, X2, X3 and X4 we have to find out such that the multiplication of all these four numbers is what? 210. Okay, so here this number is what? In right hand side there is 210. Now let's find out first of all prime factorization of this 210. So this 210, this first of all will be divided by 2, so this will be 105. This can be divided by 3, so this will be 35. This can be divided by 5, so this will be 7, and this will be divided by 7, so this will be what? 1. Okay, so this 210, this can be written as 2 into 3 into 5 into 7. Okay, this is prime factorization of 210. Now this x1 can take 4 values, 2 or 3 or 5 or 7. Okay, in the same way x2 also can take 4 values, x3 also can take 4 values, and x4 also can take 4 values. So this 4 into 4 into 4 into 4, this will be what? 4 raised to power 4. This will be what? Solution for this equation. Okay, this is one method to find out positive solution of this one. Okay, now another method we can use. So for that we have to take this x1 as what? 2 raised to power a1 into 3 raised to power b1 into 5 raised to power c1 into 7 raised to power d1. Okay, why? Because in this x1 there can be factor of 2 or 3 or 5 or 7 or different combinations of these. So I have taken all the possibilities here. Okay, in the same way x2, here also factors of 2, 3, 5 and 7 can be there. So this I am taking as 2 raised to power a2, 3 raised to power b2, 5 raised to power c2 and 7 raised to power d2. x3, that I am taking as 2 raised to power a3, 3 raised to power b3, 5 raised to power c3, 7 raised to power d3. And x4 I am taking as 2 raised to power a4, 3 raised to power b4, 5 raised to power c4 and 7 raised to power d4. Okay, so I have taken these x1, x2, x3 and x4. Now if I'll put these values here, so this all these will be multiplied here. Okay, so when all these factors of 2 will be multiplied, so if the base is same, the powers are added here in the multiplication. Okay, so power of 2 will be what? a1 plus a2 plus a3 plus a4. Okay, that is here in the left hand side, and this right hand side 210, this can be written as what? This 2 into 3 into 5 into 7. Okay, so in left hand side and right hand side, powers of 2 if I'll compare, so this will be what? This will be a1 plus a2 plus a3 plus a4. Okay, this is what? Power of 2 in the left hand side, and in right hand side that will be this power of 2 is what? 1. So this will be 1 here. Okay, now power of 3 if I'll compare, so that will be what? b1 plus b2 plus b3 plus b4 is equal to, in the right hand side power of 3 is what? 1. So this will be 1. In the same way, comparing power of 5, so c1 plus c2 plus c3 plus c4, that will be equal to 1. And by comparing power of 7, so this will be d1 plus d2 plus d3 plus d4, this will be equal to 1. Okay, so these 4 equations I got by comparing the power of 2, 3, 5 and 7 respectively in left hand side and right hand side. Okay, now solution of this equation a1 plus a2 plus a3 plus a4 is equal to 1. That can be written as 1 plus 3 minus 1c, 3 minus 1. Okay, or if I'll simplify this, so this will be what? 3 minus 1, not 3, this will be 4. How I'm writing this, that I'll explain. So this is what? 1 plus 4 minus 1c, 4 minus 1. This 1 is what? This number. 4 is what? Number of variables here on the left hand side. So this will be what? 4 minus 1 and c 4 minus 1. Okay, this is general equation. Okay, so here this will be what? 4c3. 4c3. This is also similar equation. Here also this will be what? One number of variables are 4. So this will be what? 1 plus 4 minus 1c, 4 minus 1 here, this will be again 4c3, here also this will be 4c3, and here also this will be 4c3. Okay, this 4c3 means what? 4c3 or 4c1, this can be written. Okay, that means what? This is what? Nothing but 4 only. Here also this will be what? 4, this will be 4, and this will be 4. So 4c3 is equal to what? That is 4c1, and that means what? 4. Okay, so solution of this will be what? 4, this will be 4, this will be 4, this will be 4. That also I have written here directly. So from here also I'll get what? 4. Okay, for this values of this a1, a2, a3, a4. Solution of this equation will be 4. Okay, solution of this second equation, okay, means the second equation solution will be 4, third will be 4, and fourth will be 4. So this will be what? 4 is to power 4. This will be what? Number of positive solution of this equation. Okay, but we have to find out what? Total integral solutions. Okay, so we have to consider what? Negative solutions also. Okay, so these are what? Positive. Now how many ways this x1 into x2 into x3 into x4, this can be what? 210, and some values of that, this can be negative also. Okay, so here we are multiplying 4 numbers. Okay, so either all 4 numbers are negative, then also we'll get positive number, or out of these 4, 2 numbers are negative. Okay, in that case also we'll get positive, or all 4 numbers are what? All 4 numbers are positive only, then also we'll get what? Then also we'll get this number is positive. Okay, so x1, x2, x3, x4. Okay, so if all these 4 are positive, then we'll get what? Then we will get positive number. Okay, that is what? 210, that is positive. Okay, or either any 2 will be negative. So first 2 I am taking negative, then first and third negative, then first and fourth negative. Okay, then I am taking second and third negative, then I am taking second and fourth negative, and then I am taking last 2 negative. Okay, these are what? All possible combinations when 2 numbers are negative. Okay, or all 4 can be negative. 1, 2, 3, 4. Okay, so these are all possible cases. Or how we can find out that out of these 4, any no number is negative. Okay, so 4c0, one case is this, or any 2 are negative. Okay, out of these 4, any 2 are negative. So 4c2, any 2 are negative, or all 4 are negative. That means what? 4c4. Out of these 4, all 4 are negative. So the cases will be what? 4c4. So 4c0 means no numbers are negative, means all positive. So that will be what? 4c0. This will be 1. Okay, so this 1 is what? Nothing but this case. Okay, now 4c2. 4c2 means what? Any 2 numbers out of these 4, any 2 are negative. Okay, so if I'll solve this 4c2, so I'll get what? 6 cases. Okay, so that is what? Nothing but these 6 cases. 1, 2, 3, 4, 5, 6. Any 2 numbers are negative, and all 4 are negative. Okay, so that is nothing but this case. So that is what? Only 1 case. If I'll solve this, I'll get 1. So these are what? Total 8 cases. Okay, when these numbers can be negative. Okay, so these 8 will be what? The total number of ways when these combination can be negative also. Okay, so the total number of solutions will be what? That is 4 is to power 4 into 8. Why? Because these 8 combinations will be there. So final answer is 8 into 4 is to power 4. Okay, that is option C. Okay, so this is the final answer. So next question is, tangents are drawn to the circle x square plus y square is equal to 1 at the point where it met by the circles x square plus y square minus lambda plus 6x plus 8 minus 2 lambda into y minus 3 is equal to 0. The lambda is variable. The locus of point of intersection of these tangents is, option A is 2x minus y plus 10 is equal to 0. Option B is x minus 2y minus 10 is equal to 0. Option C is x minus 2y plus 10 is equal to 0. And option D is 2x plus y minus 10 is equal to 0. Okay, so here we have given what? Tangents are drawn to the circle this. Okay, so this circle we have given, on this tangents are drawn where at the points where it is met by the circles this. Okay, so where this circle and this circle are intersecting, at those points tangents are drawn where lambda is variable, the locus of point of intersection of these tangents. Okay, so we have to find out what? Locus of point of intersection of these tangents. Okay, for these 4 options we have given here. Okay, so first of all, let us suppose graph of this circle I am drawing is this one. Okay, now see, graph of this circle, okay, that will be intersecting this circle that I have drawn this. Okay, so these are intersecting at these 2 points. Now at these intersection points, what tangents we have to draw? So tangent, if I draw, so that will be like this. Okay, and these tangents will intersect somewhere here at this point. Okay, now we have to find out what? Locus of this point of intersection of these tangents. Okay, so I am taking this coordinate of this point P, let's suppose this point is P, coordinate of this what? H comma K, this I am taking here. Okay, locus of this point I have to find out. Okay, now this is only single point, how I get the locus? So see here, this point is what? This circle is what? A variable circle. Okay, this one. Okay, so for different values of lambda, different graph of this circle I will be getting. Okay, I'll get different equations. Okay, so this circle will be what? Different in for different values of lambda. Okay, so these points I'll get different, and if I draw tangent on that one, so they will be intersecting at some other points. So locus of all those points I have to find out. Okay, so see here, this where these 2 circles are intersecting. Okay, if I'll join these intersection points, okay, so this will be what? This will be common chord of these 2 circles. Okay, and also this will be what? This will be chord of contact for this point corresponding to this circle. Okay, so this is also what? Chord of contact for this point corresponding to this circle, and this is also what? This is common chord of these 2 circles. Okay, so this is what? This is common chord and that is also equal to, corresponding to this circle and this point. This is what? This is chord of contact. This is how this chord of contact. Why? Because from this point I am drawing these tangents, and by joining these 2 points, okay, where these 2 tangents are drawn, okay, I'll get this chord. So this is also a chord of contact corresponding to that. So this common chord also and chord of contact also. So we will find out what? Equation of common chord and chord of contact, both of these, and we'll put that here. Okay, so common chord will be what? Common chord will be for this circle and this circle, that will be what? S1 minus S2 is equal to 0. Okay, so common chord that will be S1 minus S2 is equal to 0. Okay, so we'll subtract from this circle this to this circle. So x1, x square and x square, that will be cancelled. Y square and y square, that will be cancelled. 1 I'll take this side. Okay, and here there is no values of here there is no coefficient of x, so I'll take that as what? 0. So 0 minus this, so I'll get what? Lambda plus 6x. Okay, and this will be what? Minus of 8 minus 2 lambda y. So I am taking as what? 2 lambda minus 8 I am writing. Okay, so plus 2 lambda minus 8 y. Okay, this with minus sign I have written this. Okay, then this will be what? By taking it left side, this will be what? Minus 1. So minus 1 minus of minus 3, so that will be what? Plus 2. So this will be plus 2 is equal to 0. Okay, this is what? This is equation of common chord that I have got. Okay, now what? Now I will find out what? Chord of contact. Okay, so I know chord of contact is what? T is equal to 0 corresponding to this point. Okay, so chord of contact this is what? t is equal to 0. Okay, so for this circle t will be what? X1, that is x, and x1 is what here? H plus y1, so y, and y1 is what here? K. Okay, and this will be what? Minus 1 is equal to 0. Okay, this is what? Chord of contact. Okay, now this and this will be equal. Why? Because common chord is equal to chord of contact here. Okay, so this I am equating. So lambda plus 6 x plus 2 lambda minus 8 y plus 2, this equal to this thing. So xh plus yk and minus 1. This I have took here. Okay, now on the left hand side and right hand side I can compare the coefficients here. Okay, so this will be what? Lambda plus 6 by h is equal to 2 lambda minus 8 by k is equal to 2 by minus 1. This what I did, I have compared the coefficients of x, y and constant term. Okay, so from here now I'll find out what? Lambda from both of these. Okay, so from here, okay, by comparing these two I'll get what? Lambda plus 6 is equal to, okay, this will be minus 2h. By comparing these two I'll get what? 2 lambda minus 8 is equal to minus 2k. Okay, so from here I'll get what? Lambda is equal to minus 2h minus 6, and from here I'll get what? 2 lambda is equal to minus 2k plus 8. So lambda will be minus k plus 4. So from both of these I can compare what? Values of lambda. Okay, so minus 2h minus 6 is equal to minus k plus 4. Okay, so now by simplifying this, not minus 2, this minus 2, this is what? Minus 2h minus 6 is equal to minus k plus 4. Okay, now by comparing these two, by solving this, I'll get what? 2h minus k plus 10 is equal to 0. Okay, now in place of h and k, I'll put what? X and y. Okay, to get what? Locus. So this will be what? 2x minus y plus 10 is equal to 0. Why? Because locus of this point hk. Okay, this I have to find out. So that will be what? This 2x minus y plus 10 is equal to 0. That was required. Okay, so this is which option? This is 2x minus y plus 10 is equal to 0. This is option A. Okay, so this is our required answer. Our next question is the value of integration 0 से pi by 2 1 by a square cos square theta plus b square sin square theta d theta, where a and b are greater than 0 must be. Option A is greater than pi by 2 a square plus b square. Option B is equal to pi by 2ab. Option C is less than pi by 2 a square plus b square essentially, and option D is pi by ab. So we have to find out what value of this integral. Okay, so let's find out. So here we have given, let's take this I is equal to integration 0 to pi by 2 1 by a square cos square theta plus b square sin square theta d theta. Okay, now to find out this, okay, what we can do, we can divide in numerator and denominator by cos square theta. Okay, so here this dividing numerator and denominator by cos square theta. Okay, so this I will be what? Okay, this will be 0 to pi by 2. So 1 by cos square theta, this will be sec square theta divided by, this will be what? A square cos square theta will be cancelled, and this will be what? Sin square theta by cos square theta. This will be tan square theta. This will be b square tan square theta d theta. Okay, this. Okay, now see here we can substitute what? This b tan theta as what? T. Okay, because differentiation of this tan theta will be what, sec square theta. Okay, so that will be eliminated from here in the numerator. Okay, so substitute b tan theta is equal to t here. Okay, b tan theta is equal to t, this I am substituting. So this will be what, b sec square theta d theta is equal to dt. Okay, so this sec square theta d theta, this will be 1 by b dt. Okay, what about the limits? Okay, so for x equal to 0, okay, or x equal to, sorry, for theta is equal to 0 or theta is equal to 0, this t will be what? This t will be tan 0, so tan 0 means what? 0. And for theta is equal to pi by 2, theta is equal to pi by 2, this will be what? Infinite. So t will be infinite. So 0 to pi by 2, 0 to pi by 2, this limit will be what? 0 to infinite. Okay, so this I can be written as I is equal to integration 0 to infinite. Okay, and this will be what? Replacing sec square theta d theta by 1 by b dt. So this will be 1 by b dt divided by, this will be what? A square plus b tan theta is what? T. So this will be t square. Okay, now this I, this can be written as 1 by b integration 0 to infinite dt by a square plus t square. Now integration of this function I know already. Okay, integration of this is what? That will be 1 by a tan inverse t by a. Okay, so this I am writing as I is equal to 1 by b into 1 by a tan inverse t by a. Okay, and limits of this will be what? 0 to infinite. Okay, that I'll put here. So this I will be, this a I am taking outside, this will be 1 by ab, and this will be what? Tan inverse, this will be what? Tan inverse infinite by a minus tan inverse 0 by a. Okay, this limit I have put. Okay, upper limit and lower limit. Okay, so this I will be 1 by ab, and tan inverse infinite. Okay, this will be what? Pi by 2, and this will be what? Tan inverse 0, this is 0. Okay, so this will be what? Pi by 2 ab. Okay, so the required value of integration is what? Pi by 2 ab, which is here in option B. So our option B will be correct. Okay, so this is our final answer.